So today let's take a look at those bloody devices which women use to style their hair, to straighten it or dry it or curl it or whatever. It basically is a powerful heater inside of a tiny plastic housing, which is a bit dodgy, and there is also a fan blowing through it, and the hot air comes from the inside of the brush and dries the hair or curls it. It usually has more power settings like off, cold, medium, hot, and sometimes some special functions like an ionizer creating negative ions, which I'm not sure if it does have any effect or is it just for advertising. And of course it has a cable coming to it, which makes it even more tricky because in use it's being rotated and moved, and so the cable suffers a lot of stress. It's being twisted and bent, and of course after some time it ends up broken. And this one is also broken already and fixed using a sticky tape. As you can see, women are quite inventive at fixing it. There is also another sticky tape here, another sticky tape here around it. So those are quite amazing devices. 1000 watt heater inside of a tiny plastic housing. And this one is also 1000 watts. And this one is 700 watts. It's often being used in a bathroom where it can come into contact with water, and it's being stored near a shower where the water can splash on it. So as you can see, women have to be quite brave to actually use it. And a 1000 watt heater blowing on your head, they must have heads of asbestos. And it sometimes falls on the ground, it cracks, and it's being glued together using a nail polish. And some of them are a completely wrong design from the beginning. This one is from my mother. She bought it recently and realized it doesn't work. Because those proper ones, and here's my dog, those proper ones have the hot air coming from the inside of the brush. But this one has the air coming from those holes around it, not from the inside. And she says it doesn't work. So this design is just like a square wheel. And also the switch is getting stuck in a completely new device. So now let's take a look inside one of those with the help of my dog here. So I've already opened it partially, and as you can see there are those two rings which click on it, and there are absolutely no screws. The air actually comes in through this, and it comes out here into this, and there are two halves which click together using those 6 plastic bits. And here's the cable with the rotary contact, and it goes into this, into those contacts. So you can actually turn it in it. But even with this it still gets twisted a lot. As you can see, the cable is twisted anyway. And this one also looks quite scary if it accidentally comes out. There is some interference filter with a capacitor and its discharging resistor. And there are some switches, a 3-position switch and another switch. So it's for off, medium, high, and there is also some cold air setting using another switch. And those switches are held in place using sticky tape. Those blue sticky tapes are original. And here's the fan. And can I open it like this? Yes. And it comes apart. And there is another layer, probably a mica. And here's the heater. So as you can see, it has 3 layers. This layer from the outside, this layer, and a layer of mica. It has more layers, probably to isolate the heat, so it's not too hot to touch from the outside, and so the plastic doesn't melt. And the air is coming from the fan through the heater, but some portion of the air blows on the outside of the mica. to prevent this plastic from melting. Because remember, this heater is 1000 watts, that's quite a lot. So here is the fan, and here its motor. It looks like a normal DC low voltage brushed motor. It has a bridge rectifier made of discrete diodes to rectify the voltage for the fan. And there is also some interference capacitor in it, probably. And this one is the main heater. And this small one is probably a resistive dropper for the fan. Here you can see the switches. And there are two power settings, and the lower one is actually achieved by putting a diode in series with the heater to pass just one half cycle and to halve the power. So here's the diode, halving the power of it, but why it's in the center of the heater? Bloody hell! It must be crazy hot inside of here. A semiconductor inside of a 1000 watt heater. Seriously? Is this a good idea? Why it's not here in the cold air before it enters the heater? So as you can see, sometimes the design is just absolutely crazy and you just can't get it. And here's a fuse for the motor probably, and another fuse for the heater. It looks like a reversible thermal fuse, a bimetallic strip that turns it off if it overheats. And this overheat protection is quite important because this motor can easily fail. The power supply of it can fail, the motor itself can fail, it can seize, it can get full of dust or hair and stop, or it's dirty and not enough air is passing through it, and then this would overheat. So there is a thermal fuse to shut it down, because otherwise you have a 1000 watt heater inside of plastic housing with no air circulation, and this is gonna end up quite badly. And there is also a mysterious component in the center of it here. Is it a high voltage power supply for the negative ion generator? And that's weird. It has 3 connections. 2 wires coming in from a mains, and the last wire is here. And it doesn't go anywhere. It's just a wire which ends here. So it ionizes the air using a high voltage. Does it have any useful effect, or is it just an advertising trick? I'm not sure. But now let's try to reverse engineer it. So here's the schematic of it, which is not so complicated. The mains comes in. Here is the interference capacitor with its discharging resistor. Here is the main switch with 3 positions: off, medium and high. In the medium position, this contact is activated, and in the high position both of them are actually connected with the mains. So in the medium setting it goes directly into this high voltage generator, but into the rest of the circuitry it goes via this diode, passing just one half cycle, and so it runs at half of the power. But in the high power position, the switch bypasses this diode, so the entire circuitry gets the full mains sine wave. So the high voltage generator always gets the full mains voltage, but those heaters can get either just one half cycle or also the full mains voltage. Here is the bimetallic strip for the overheat protection, and here's the main heater with the highest power. It has a switch in series for the cold setting. When the switch is off, only the auxiliary heater is running, which is in series with the fan, and it works as a resistive dropper for it. The fan motor is DC, so it has a bridge rectifier for it, and there is also an interference capacitor on it. In a cold setting, only the auxiliary heater is running, which is just 137 watts, which is not much, so the air coming from it is almost cold. And in a hot setting, both heaters are running, and this is in total almost 1000 watts. The power can be reduced using this diode, but it also reduces the speed of this fan. So it's more or less the entire schematic, but now I have to take a closer look at this high voltage power supply. The high voltage power supply is hidden in the middle of it. Can I get it out somehow? It's not easy because those diodes are soldered onto the motor and onto those contacts. Does it come out? Yes, it does. It's in a plastic package, which is filled with resin. It has 3 connections, the mains coming in and the output. So the input is 180 to 250 volts, 50 or 60 hertz, and the output is minus 1.5 kilovolts up to minus 3 kilovolts, and the power is 1 watt. Is it a switching power supply or just a multiplier? But of course the multiplier is much more likely. But now let's try to put it back together and identify its failure. So it's reassembled. Let's try to turn it on and let's see. There's power in it. Here's the switch and nothing. So it seems the cable is actually broken inside of the isolation. Which is not a surprise because it suffers a lot of strain here. Maybe it's possible to buy a spare plug with this termination, but let's do a quick dirty fix. It's possible to cut it and solder it permanently into the machine, but of course this is not perfect because you lose this rotary joint. So let's fix it, and this is just a very cheap, very dirty quick fix. It's not recommended because you lose the rotary joint and the cable is going to suffer from twisting. So let's tin it, put rosin on it. It's better if the solder slightly soaks into the wire inside of the isolation because this makes the wire stronger. Otherwise the wire can easily break right here. And before applying the solder I twisted it. So now let's solder it in place. And that's it. But of course, it's a good idea to put this one on it first. That's it. Now let's try to reassemble it. This is just horrible, of course. And this is simply how not to do it. So let's test it. It works. And the other one, it's also absolutely horrible cable. And it's also dirty here. So let's try to fix the cable and clean it. It also has a lot of hair in it. And the same plug. It's quite a similar construction, but it has an extra voltage switch for different mains voltages, 110 and 230 volts. So let's take a look inside. Here's the heater, and the switches, the motor, and no high voltage generator. Here's the power limiting diode, which is in a better place than in the other one. And this motor seems to have just 2 diodes instead of a bridge, going from 2 taps on the heater. And the motor has an electrolytic capacitor on it, which is probably not very happy in this hot environment. So here's the schematic of it, which is a little bit overcomplicated because there are 5 heaters in it, but it could be even worse. So the mains comes in, here is the interference capacitor with its discharging resistor, here is the power switch with half or full power using the diode, and a bimetal protection. So this part is the same as in the other one. Now it's getting a bit more complex because there is this mains voltage selector. But it still makes sense. There are 5 heaters, but this one is 1/2 of the main heater. This is the other half of the main heater, and this one is the auxiliary heater. So the main heater is split into 2 halves. This is one, and this all is the other half. Those two halves can be either in series or in parallel according to the mains voltage. For the higher voltages, it's all in series and the current goes via all of them in series like this and back. For the lower voltages, it's in parallel, so the power goes via one section and back, and also via the other section and back. So now they are in parallel. And this half of it has some taps on it to get the low voltage for the fan. It's basically a resistive divider. One half cycle goes via this diode and the other one goes via this diode. So the motor can get both half cycles. Of course, when it's running at a full power. But when it's running at half power, the mains goes via this diode. So the heater gets just one half cycle and its power is halved. And also this fan gets just one half cycle and it's running slower. Now there is this switch for a special function called care. Now in a normal operation it's on, and when the care function is activated, it's off. In a normal operation it's on, so the current goes into the motor via those diodes, and it doesn't have to go via this heater because it goes via the least resistance. Just via a diode and no heater, so in a normal operation this heater has no current in it. But when the care function is activated, this switch is off, so the current can't go here, so it only goes here, via this heater and this diode. So the power is reduced because this extra resistance in series, and also because this diode only passes one half cycle. Now because of this diode, the diode at the switch has no effect. So both positions of this switch are acting the same. Now for the higher mains voltages, the current goes via this heater, this diode, the fan, and those three heaters and back, and this one is not in use. And for the lower voltages, the current goes via this heater, diode, fan, and then it splits via those two heaters and back, and also via this and this heater and back. With the care function, the fan is running about 75%, or faster than this, but slower than this. The main point of the care function probably is to reduce the power, so the air temperature is lower. With the care function, the heating power is reduced, but the fan is still running fast because there is no heater in parallel to it. I've got two pieces of the same type, so let's measure the current using the other one. Now with the care function, those two positions are now acting the same. With the care function, all of the current has to go via this diode, and the current is 1.38 amps, but this type of diode is rated for just 1 amp. So it's a bit dodgy design. And also this capacitor is a Bloody hell! My pen just exploded. So this capacitor is a questionable choice because its capacity is way too low for a smoothing. But it's also not suitable as an interference suppression because it's an electrolytic capacitor which has a high internal resistance and inductance. And electrolytic capacitors are sensitive to heat, so putting it into such device is a bit tricky. The capacity is way too low for any smoothing, but a motor actually doesn't require smoothing, it can run with a pulsing current. So it should have been a ceramic capacitor, which is good as an interference filter because it has a low internal resistance and inductance, and it's also resistant to heat. The other one has a 220 nano ceramic capacitor. So now you know how those devices work. And you also know that when using a pen as a pointer, you shouldn't press it too hard. So this is Wild, and see you in my next videos, and thanks to all of my patrons on Patreon. I really appreciate your support. But now, of course, let's fix the cable and put it back together. Let's use some strain relief, glue it back, and that's it. And now I have to get some hair.